Okay, this is lesson 4.3, graphing proportional relationships. And if you recall, this is going to be a lot of review from what you learned in 7th grade regarding the constant of proportionality and the equation for that. So the key idea from your book, this is direct variation. When two quantities x and y are proportional, the relationship can be represented by the direct variation equation. Y is equal to mx, where m is the constant of proportionality. In this equation, m is the slope of the line. So the graph of y is equal to mx is a line with a slope of m that passes through the origin. And if you notice on the graph, you can see the slope. You can see the slope. Right here, it is the y coordinate when x is equal to 1. So let's think about that for a minute. So we have this original equation, y is equal to mx, since m is the slope. At any time, if we want to know what m is equal to, we can divide both sides by x, okay, and get the ratio y over x is equal to m. So no matter what ordered pair you would use, if you took y and divided by x, you would get that constant rate. And that was how we determined if a relationship was proportional. 1, it was a straight line and it went through the origin. 2, it had a constant rate. So if you took y divided by x, you got the same thing for every value in the table. So looking at this example, it's right out of your textbook. It says the cost y in dollars for x gigabytes of data on an internet plan is represented by y is equal to 10x. So they give you the equation. Graph the equation and interpret the slope. It says, since the equation shows that the slope m is equal to 10, we know, like if we made a table, right, of x and y values, and we plugged in 0, right, y would be equal to 10 times 0. We know that y would be equal to 0. If we plugged in a value for 1, 10 times 1. Okay, so just like you've done before. And this is what they have graphed. They have graphed 0, 0, and 1, comma 10. You plot the points and draw the line through the points. Negative values of x do not make sense in the context of this problem, so you really only need to graph in the first quadrant, and that's going to be true for about everything we're talking about. The slope indicates that the cost is $10 per gigabyte. So this is a really important concept right here. This is interpreting the slope. What does the slope mean? The slope means that the unit cost is $10 per gigabyte. That's the information we get from this equation and this relationship. All right, so if we wanted to graph the equation and interpret the slope, in this situation, the cost y in dollars for x gigabytes of data on an internet plan is represented by y is equal to 12x. So kind of using the same information, we have our equation, right? We know the slope is 12. We could make a little table to graph. And if we plug in 0, we get 0. And if we plug in 1, we get 12. If we plugged in 2, we'd get 24, etc. So whenever you're making a graph, and if you have to freehand the graph, go ahead and make your labels. So this y-axis represents the cost, and that's in dollars. The x-axis represents the gigabytes. Okay, well, my G's are all cut off there. So if we labeled the graph, I'm going over that, sorry about that. Here, I'll count by 5s. Okay, that I could label some of these points. We know that we have 0, 0. We know that we have 1, 12. And we could draw this line going through the origin, okay? We need to interpret the slope. And in this case, from this equation, if the slope is 12, this means the slope indicates that the cost is $12 per gigabyte. And I'll go ahead and abbreviate that. $12 per gigabyte. If you need to write the equation, sometimes you'll have to come up with ways to calculate the slope. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. So y is the weight on Titan, x is the weight on Earth. An object that weighs 105 pounds on Earth weighs 15 on Titan. So from this, I have this ordered pair, 105, 15. I know that the x-coordinate is indicated right here. The y-coordinate is right there. So if I'm substituting that into this direct variation equation, y is equal to mx, substitute in 15 for y and 105 for x, and I'm going to kind of bring this work down here. If I have 15 is equal to m times 105, and I want to solve for m, I will undo this multiplication. I'll divide by 105 on both sides of the equation. 15 over 105 can be simplified to 1/7 because 15, if I divide out the common factor of 15, I'll get 1/7. So that's how I get that. So then I can get this form of the equation. Y is equal to 1/7 of x. Now this information is going to be important for the next part of the example. Again, also in your textbook. So how much would a chunk of ice weigh that is 3.5 pounds on Titan weigh on Earth? So if you substitute in the 3.5 in terms of y for y, because that's what the pounds on Titan would be, and we're solving for x, remember that if you have 1/7 times x, 1/7 times its reciprocal is equal to 1, so times both sides by 7, basically. That'll cancel the 7s. So times 7 will give you this 24.5 pounds on Earth. All right, so it's going to be a lot of keeping track and understanding which one is the independent variable, which one is the dependent variable. In the last example, we had the equation y is equal to 1/7 of x, where y was equal to the weight on Titan and x was the weight on Earth. In the last example, we had this equation. So how much would a spacecraft that weighs 3,500 kilograms on Earth weigh on Titan? So we really want to know, what does y equal? Y would be equal to 1/7 of the weight on Earth, which was 3,500 kilograms. So 1/7 times the 3,500. And we would find that y is equal to 500 kilograms. That's how much it would weigh on Titan. So we can use that equation to get more information. Okay, our final example that we're going to do is comparing the proportional relationships. So in this example in your book, it talks about the distance in meters that a 4-person ski lift travels in x seconds, represented by this equation. So they give us the equation right here, y is equal to 2.5x. This graph shows a 2-person lift. So we can use information, because we see 2 points on the graph, to calculate the slope for the 2-person lift, okay? So for the 4-person lift, the slope is in the equation as 2.5 meters, right, per second. When we take 12 minus 4 over 6 minus 2, we get 2. So the 4-person lift is faster than the 2-person lift. 2.5 meters per second is faster than 2 meters per second. The graph, if we were to graph the 4-person over the 2-person in the same coordinate plane, it would look like this. Okay, so the graph of the equation compares the steepness of the two graphs, and so that we can interpret that the 4-person is faster. So looking at this table, we now have a T-bar ski lift, and this gives us the distance in meters that it travels in x seconds. So let's compare it to the other two. So I've kept the graph there. So one thing we would want to do is calculate the slope. It could be done a couple different ways. M will be equal to the change in y over the change in x, and we have a table. So we could take any 2 points. If we wanted to take these two right here, we could take 4.5 minus 2.25, change in y over change in x. So we have this equation, y is equal to 2.25x. And how would that compare, right? If we remember, the 4-person was 4 is equal to 2.5x. The 2-person is y is equal to 2x. So this equation, in terms of speed, would be somewhere in the middle right here of the two. So its graph would also fall in the middle somewhere here. So it would be slower than the 4-person, but faster than the 2-person. Another way of calculating the slope, especially when you look at a table like this, if you have x equal to 1, the slope is given by the y-coordinate. So sometimes you don't have that and it's too hard to estimate, but if you do, then you can see the slope right there. So to compare the speeds, this is slower than the 4-person lift, but faster than the 2-person lift.